Hey y'all, Miss Harper here for our graphing quadratics using our calculator. Y'all are going to love it. It's going to be so great. Alright, so how can I graph a quadratic? So a couple things first. We need to make sure that our quadratic is in standard form. Alright, meaning it looks like y equals ax squared plus bx plus c. Alright, once it looks like that, then step 2, we can plug in to y equals in our calc. Okay, so let's go ahead and do that first step. So first of all, my quadratic right here for example 1 is already in standard form. So I'm going to open up my calculator. You need to make sure that you have your calculator in your hands, that you're following along with this, and not just going through the motions here and watching me do it. You need to practice doing this on your own too. So it is y equals x squared plus 4x plus 4x plus 2. Alright, and then once we do that, we can go click on our graph and see what this thing is going to look like. Now right here, if your calculator screen is messed up, go ahead and reset your calculator, second plus 712, and then you can go ahead and join back with us. Alright, so here's my cute little guy right here. He's adorable. Now I can't just guess what all these points are, so I'm gonna show you guys how in your calculator he will tell you kind of those key features that we're looking for. So how can I find the vertex? So the three most important parts are that we find the vertex and the two roots, or our two x-intercepts, okay? So how do we find the vertex? So to find the vertex, we are going to go to second trace, and then according to what kind of graph we have, we're going to use the max or min function. Alright, so it depends. If it opens up, you're going to use the minimum. If it opens down, you're going to use the maximum option. Alright, and then, okay, let's go ahead and try this. And I'm going to show you what we do, and then we'll kind of write it into words in a second. So here we go here. So I'm going to go second trace. And in this case, I have a minimum. So I'm going to scroll here to option number 3, and I'm trying to find the minimum. Now look, it's going to ask us some questions. So see down here where it says left bound. So what that means is it wants us to scroll this little cursor over here to the left side of our vertex. So you can either left arrow over here, alright, and then you hit enter. So it's asking, pick a point to the left of the vertex, pick a point to the right of the vertex, and then I'll tell you what the vertex is. So now it asks us to go right bound, and I hit enter again. Alright, so notice up here that these two little arrows are pointing towards each other, and I kind of have the vertex lying there in the middle. Alright, so now it's asking me, do you want me to guess? And I'm going to hit enter one more time and say, yes, please take a guess. And it tells me that my minimum point is at -2, -2, and that is our vertex. Alright, so we got -2, -2 for the vertex. Alright, so second trace, max min, and then let's go ahead and add the extra note. So we need to go to the left of vertex, enter, to the right, enter, enter. Alright, that last one you have to hit enter 2 different times. Alright, so now if I want to graph this thing, I'm going to go ahead and plot that point over here. So -2, -2 is my vertex. Alright, on this next part we want to find our roots. Alright, remember the roots are the rocks, and basically those are all of our x-intercepts. Okay, so let's figure out how we do our x-intercepts. We're actually going to do the same process. We're going to go to second trace, and now this time one of the words, whenever we go in here, which word do you think it's going to be? Well, we are going to use option number 2 that says 0. All right, remember this stands for roots, zeros, x-intercepts, and solutions. So we're going to find the 0 function here. And then we do the same thing. We go left bound, right bound, and then we hit enter at the end for it to take the guess. All right, so let's go ahead and try that. Now the thing here is we have to do it 2 times. So we have 2 separate roots to look at. So I'm going to go ahead and move my cursor over here to the left side of my x-intercept. And then I'm going to hit enter. And now I'm going to move it to the right side of my x-intercept. I'm going to hit enter again, and I do want it to take a guess, so I hit enter one more time. We're going to go ahead and round these to 1 decimal place today. So this is going to be at negative 3.40. Alright, so our first one is going to be at negative 3.40. I know what you're thinking. You're like, oh my gosh, Miss Harper hates decimals, but in this case, I will allow it. But we only found one of them, so we need to go ahead and do the second one as well. So I'm going to do the same process. Second trace. I want to find my second 0. Now this is where it gets kind of weird. So now it's asking to go left again. So to the left of this x-intercept would be over here on this side. So I hit enter. And then I move it over to the right of the intercept and hit enter. And then I want it to take a guess, so I hit enter one more time. And it tells me negative 0.50, but that is actually going to round up. So I'm going to call that negative 0.60. Negative 0.60. And those would be our 2 roots. So now if I try to plot those, negative 1, negative 2, negative 3, and a little bit more. And then negative, it's just after negative 1/2, which is about right here. Alright, obviously I can tell that this thing is going to be pointing up, and now I can draw in my curvy parabola. Okay, make sure that you're making it a U shape and not a V shape. Alright, let's go ahead and point out some of these key features over here. Alright, this thing is positive. It has a minimum. Our vertex we decided was at negative 2, negative 2. Our 2 roots were at negative 3.40 and negative 0.60. Alright, and then our axis of symmetry. Well, where does the axis of symmetry come from? Remember, it's related to the vertex. So if you need to draw in your axis of symmetry to help you find it, you can. Alright, and that's cutting through there at negative 1, negative 2. Alright, and remember that matches the x value of your vertex. So there are the key features, and that's how we find them in the calculator. If you need some help right now with going with the kind of left bound and right bound thing, go ahead and pause your video, raise your hand, and we can come over and answer your questions for you. Let's go ahead and try these 2 examples. I'm going to actually do example number 2 with you. So let's try out the same process. Go ahead and go to y equals, clear this out, and we're going to type in our quadratic function, 4/9 x minus 4 squared minus 4. Oh crud, I messed that up because I wasn't paying attention. 4/9. Okay, now this will be right. X minus 4 squared minus 4. So make sure that you're typing it in exactly how it looks on your assignment. Click on your graph. Let's go see what this thing looks like. Maybe. And oh, there he is. Alright, so you can tell he got a little bit wider. So I can go ahead and describe some of my key features if I wanted to right now, but I want to go ahead and find my vertex first. Well, is this thing positive or negative? We can clearly see it's positive. So therefore it has a minimum, and let's find our vertex. So I go to second trace. I'm trying to find my minimum point, option number 3. And now this is where I have to go left and right. So I'm going to scroll this over to the left side of my vertex, which can be here. You kind of want to be somewhat close. And then somewhere over here to the right of the vertex, and then I hit enter one more time for it to take a guess. Alright, sometimes this is a calculator, it's trying to take its best guess, so when you get a bunch of these decimals, we can assume this to be the 0.4, -4 here. Alright, 4, -4. Alright, now let's go ahead and find our roots. Doing the same thing, we go second trace, and this time I'm trying to find my 0. So I'm going to go with my left one first. So I got to scroll my little cursor up here to the left side of my x-intercept, hit enter, scroll it down here to the right side, hit enter, and then hit enter one more time for it to take a guess. And that one tells us our 0 is at 1, 0. 1, 0. Let's go ahead and find our second one. Second trace, finding my other 0. Now I have to do the same thing. Put your cursor to the left side of your x-intercept, hit enter. Put your cursor to the right side of the x-intercept and hit enter one more time. And this 0 is at 7, 0. 7, 0. Now you can also find some of these points that, like these ones are nice whole numbers, so I could go to my table and I could also find these here in my table. So let's see, like the 0.10, we see that right here. And then if I scroll down a few times, we would also find the 0.70 right here. But again, that only happens whenever they're nice, pretty whole numbers. So we definitely want to use the second trace function. Remember that your axis of symmetry comes from the x value of your vertex, so it is x equals 4. So now that I know all that information, let's go ahead and draw those things out. So I'm going to start with my vertex. All right, +4, -4 is right here. I can go ahead and draw in my axis of symmetry. And then I want to draw in my two roots. So I have 1, 0, and 1, 2, 3, 4, 5, 6, 7, 0. And then I'm going to give it a nice, pretty little curve. Make sure it's kind of a U shape like that. All right. So I want you guys to pause the note video here, and I want you to try the second one out on your, or this next example on your own. However, look at your equation. It is not in standard form yet. All right, so how can we make this into a y equals? Well, first I need to add the 7 to the opposite side. So I'm going to add the 7 to both sides, and remember, numbers go with numbers. So my new equation is going to be y equals -2x squared plus 8x plus 20. And now I want you to pause the video and go try this one on your own. You can come back and check and see how you did. Alright, I'm going to go ahead and come back on here real quick because I realized that this was a crazy problem. So if you were having a hard time finding your maximum, in this case, you needed to zoom out one time. So you go to zoom, you press zoom out, and then you hit enter one time. So I did that for my vertex, and for my vertex point I got 228. And so if I go back into my calculator, I went and zoomed back in so I can see my graph right now, so I can see my intercepts a little bit better. So now I'm going to find my zeros here. So 2. So now this is kind of tricky. So the left side would now be down here to the left of my x-intercept, and then somewhere over here to the right, and then hit enter one more time. We get -1.7 and 0. So -1.70. And I'm going to go ahead and do it to my other one too. Sorry I left you guys hanging on a bad example. Second trace, I'm finding my second 0. So I'm going to click my cursor all the way over. Maybe. Hopefully he's coming back. There he is. Alright, so now this is the left side, enter. And now if I click down, this would be the right side, and I hit enter one more time, and we get 5.70. 5.70. Alright, and then our axis of symmetry comes from the x value of our vertex, so that's x equals 2. This graph was negative, and it had a maximum. Alright, so unfortunately this is kind of bad, so let's just pretend 228 is somewhere, so go over 2 and then way up here to 228. That's going to be our vertex point. And then our roots are at negative 1.7, which is between negative 1 and negative 2, and 5.7, which is between 5 and 6. 1, 2, 3, 4, 5, somewhere in here. And then very nicely, I'm going to draw in a big old U shape. And I can even draw in my axis of symmetry. Alright, so hopefully that's the only bad example we come across today. If you need help with the left bound and right bound, I will probably talk to you guys as a class about that. If you need any extra help, come see me in tutorials.